Good morning, Algebra 2. Welcome to a fun-filled lesson of learning and algebra and all that good stuff that you know and love. So today I'm going to have you work on a skill that you learned back in Algebra 1, but you haven't used it in geometry, so you might be a little bit rusty. So this is just going to be a quick overview with a number of examples for different ways to solve a system of equations. Now, like you see up on the board here on the screen, it says that a system of equations simply means it's a group of two or more equations. So this word system means we've got more than one. So this is a system of equations. And when we solve a system of equations, well, we're looking for the solution. Remember, that was a big part of our last unit. I talked about the solution to an equation was the value that makes that one equation, the original problem, true. Well, here the solution to a system of equations is now going to be not just one variable, but it's something we call an ordered pair. And an ordered pair is basically an x value and a y value. Think of like a coordinate, x comma y. And the special thing about this ordered pair is that it's going to solve all the equations. So if our system has typically two equations, it's going to be a single x value and a single y value that when we plug it into those two equations, they make both of them true. And it's not two different x's or two different y's, it's one single ordered pair. And we could even have a system of equation with 10 equations, and there might be a single ordered pair that makes all of them work. Or actually, that had to be an ordered decalit. I don't know what you call 10 numbers at once. Anyways, the two methods that we're going to learn today are called substitution and elimination. These are our two algebraic methods. We also can solve them graphically, but we'll work on that in the next unit, or the next lesson, I mean, because that's a more fun one to do when we're face-to-face. So here we go. We're starting off by learning about substitution. And the word substitute means to replace. Like if there's a substitute teacher, that teacher is taking the place of the regular teacher. And so with this substitution method, we literally are substituting or replacing or plugging in one equation into the other one. So I'm substituting an entire equation for one of the variables. We substitute one variable out and we substitute in a different equation. Here are your 4 steps that I want you to keep on referring back to whenever you are working with these system of equations when you're going to use the substitution method. So step number 1, you're going to set one equation equal to x or equal to y. Hopefully, you'll already have one equation set up. And when I say equal to x or equal to y, I mean the equation looks like this. X equals blah, blah, blah. Or maybe it's going to be y equals blah, blah, blah. And all the other numbers and variables and letters are off to the right. But the key thing is that there's only one variable by itself on one side of the equal sign. Now, sometimes it'll already be set up that way. Other times it won't be set up. So maybe there'd be like a 3 plus x equals blah, blah. If that were the case, you just have to cancel it out by like subtracting a 3 from both sides. And you want to make it so that it is just a 3, or I'm sorry, just an x equals, and then the rest of the equation. So that's step 1, getting one of those equations equal to x or y. Step 2, once you have it as just an x equals or just a y equals, you're going to plug it into the other equation. This is the substitution step. So if y equals some big expression over here, I basically am going to take this entire equation that the y is equal to, or this expression, and plug it in to the other problem. And again, I'll show you this in a few examples in just a moment. Once you've plugged one equation into the other equation, or substituted, then you're just going to solve that remaining equation for whichever variable is remaining. So if you plugged y into the x equation or the x into the y equation, you'll essentially only have x's or you'll only have y's, and all you need to do is solve for that variable, which means you figure out what number that variable should equal. After you solve for that variable, then you're going to plug it back into one of those original equations and just solve for the other variable. So if you solved for x first, then in this step you would solve for y, or the opposite. If I solved for y first, then in this last step I would solve for the x. Once you have both the x and the y value, well then that would be your solution. x comma y. We should probably test that, right, by plugging it back in to make sure they work. Don't want any of those extraneous solutions. Let's take a look at some examples. Example 1. So I've got two equations here, right? These two form a system. All right, this is a system of equations because there are more than one of them. And I'm looking for a single x comma y pairing that if I plug that x here and here, okay, so this has to be the same number that I plug in for x, and then for the y's, I plug in the same number here and here, so this is also equal to the same number, that both those equations would be true, meaning the left side of the equal sign would equal the right side of the equal sign in both of these equations. So that's our goal. We're going to do this with substitution. Now, step 1 says to set one of the equations equal to x or equal to y, and luckily we already have that down here. See how this equation is written as x equals, and then this is all that blah blah that I was telling you about earlier. So x equals something. So what we want to think of, if x equals this 3/2 y minus 8, that means that they're the same thing. That's what equals means. So instead of writing an x, I could write whatever x is equal to, because x literally is this 3/2 y minus 8. They're the same thing. So here's this substitution step. I'm going to go into my other equation, wherever there's an x. Okay, so right here there's an x. But I know that x is the same thing as 3/2 y minus 8. So what do? Well, I take this part that I boxed up and I substitute it in for x in the other equation. So here's what this is going to look like. So I'm going to rewrite this first equation now. And instead of writing 2 times x, well, I'm going to write whatever x is equal to, which was the part in the box. So 2 times x is really 2 times 3/2 y minus 8. Then I write the rest of the equation, plus 3y equals 8. So this equation here has just been rewritten up here, but the only difference is instead of writing that variable x, I've now written what x is equal to, the 3/2 y minus 8. Now if you notice that this equation here now has a y there and a y there, and there are no more x's, and that's what we wanted. By substituting in place of the x, I've now gotten rid of one variable. We have one remaining. Our goal here is to simplify it to solve this for y. We want to get the y all by itself on one side now. So we're solving the equation. So we have some steps we can do. First off, there's a 2 in front of a set of parentheses. So we can get rid of that by distributing. I'm sure you all remember the distribution property, right? I take this 2 and I kind of make these little rainbows inside of the parentheses, so it's being multiplied by everything. Now, I know you're getting scared with that fraction right there, but it's very easy. If I'm doing 2 times 3/2, all I'm really doing is, I can think of this as like 2/1, and then I just have to multiply the numerators together, and I multiply the denominators together and simplify. So 2 times 3 is 6, where 1 times 2 is 2. And then I've got this fraction here. I can simplify that further because 6 divided by 2 is just 3. So when I substitute that in for that first piece, it's going to just equal 3. All right, so I've got 2 times 3/2 y is actually equal to 3y. And then 2 times -8 is -16. And then I've got this plus 3y equals 8 still. All right, I'm going to combine like terms. I have a 3y here and plus 3y there. Those are like terms. I can combine them. So if I had 3y and I add 3 more y, I have a total of 6y. I still have this minus 16 right above me, and then just equals 8. Keep solving from here. I'm going to add 16 to both sides. So now I've got 6y equals, well, 8 plus 16 is 24. My last step is to divide both sides by 6, and we see that y equals 4. So we've got a solution now. Y is equal to 4. But because this is a system of equations, our final solution has to be both an x value and a y value. Now, right now, we found out the value for y. We know that the y is a 4. So this something comma 4 will be our final answer. Well, how do I get that x value? Pretty simple. All we need to do is plug in that value of y equal to 4, and I can plug it back in to either of these equations. It doesn't matter which one. I'm going to get the same value for x. Now, in my opinion, it's easier to plug it in for that first one that we put a box around way back in the first step, okay? Because I know to get x, I just have to take 3/2 times y and then subtract 8. Well, I know what y is. So to find my x, I'm going to take 3/2 times y. Well, I know that y is a 4. And then subtract 8. So x equals 3/2 times 4. Remember, to do this, all I do is take this 3, the numerator, times this 4, times that whole number. Well, 3 times 4 is 12. And then I still have this denominator of a 2 that I haven't taken care of, right? That's the 2 that's right here. And 12 divided by 2 is just 6. And then I know 6 minus 8 is a -2. And so now, we have solved the system because I have an x value right here of -2. My y value, well, we had found that previously. We know that that's 4. So -2 comma 4, this is officially the solution to this system of equations. You can plug the -2 in for x, you can plug the 4 in for y into both of these equations, and they both will come out true. The left sides will equal the right side. I'm not going to do that for you right now. If you'd like, feel free to try that on your own on a rainy day. All right, here's another type of problem we've got. Now remember, our first step for substitution is to set one equation equal to just a variable, like get it as x equals or y equals. Since this doesn't have any of those yet, it's not just an x equals or a y equals, we need to do some rearranging. So what we can do is cancel some stuff out, move things to the other side. For example, if I look at this bottom equation here, it's almost written as y equals by itself, except for this plus 2x. I wish I didn't have that plus 2x there, then it would be written as just a y equals something. So why don't we do that? I'm going to get rid of this 2x by just subtracting it from both sides. Now on the left side, the 2x's cancel out, and I'm now left with y equals, which is great. But now on the right side, I have a 6 minus 2x. Now those aren't like terms, right? One is just a number, one of them has a variable. I can't combine them and say like 4x or something like that. Instead, we're just going to write them out right next to each other. So I have a 6 minus 2x. So this is going to become my new equation. So I'm going to ignore this stuff right here and pretend that what I've written in red is my new second equation. And we're going to use this one for substitution. So right now I see that y is equal to 6 minus 2x. And so 6 minus 2x is the same thing as y. So I'm going to substitute it in to the other equation. Make sure you substitute that into the opposite equation. If you do it in the same equation, it will not work out. So I'm now going to rewrite that top equation, the y minus 1/2 x equals 1. But instead of writing this y, I'm going to write what the y is equal to, what I boxed up in that previous step. So I'm going to start by writing 6 minus 2x. So that's the y. Now after the y in that first equation comes the minus 1/2 x equals 1. Oh, these fractions are terrible, aren't they? So now we're just going to solve this for x. As x is the only variable remaining, we've got to combine like terms. So I have 6 minus, well, if I have negative 2x and I subtract 1/2 x, well, that leaves me with negative 2 and 1/2 x equals 1. Now, I know I mentioned in an earlier lesson that you don't need to do mixed numbers. And in fact, it's going to be easier if we write these fractions as improper fractions. If you remember a little trick to do that, basically take the number out front and the number in the bottom, and you multiply them together. Okay, so 2 times 2, and then you add the number that's up top, which is a 1. And then you leave the same denominator. So I'm going to rewrite this as 6 minus, now this fraction, 2.5, is the same thing as, well, 2 times 2 is 4. 2 plus 1 is 5. I keep the same denominator of a 2. So 2.5 is the same thing as 5 halves, which makes sense because 5 divided by 2 is 2.5, or 5 and 1/2. Okay. Sorry, we've got a PA announcement going right now. Hopefully it will stop pretty soon. Didn't plan on that. All right, so here's our equation, and now we want to get the x by itself, so I'm going to subtract 6 from both sides. That leaves you with negative 5 halves x equals, well, 1 minus 6 is negative 5. And then the last thing is, we have to get rid of that fraction in front, negative 5 halves. Well, first off, I can get rid of the negative sign pretty easily, because if I just flip the signs, essentially I'm dividing both sides by a negative 1. So if I divide that left side by a negative 1, and I divide the right side by a negative 1, the negatives disappear, and I'm left with 5 halves x equals 5. Okay, that's looking a little bit better. It's not as scary. So then my last step here is going to be, canceling out 5 halves. Now, this is a skill that we are going to be using throughout the year. It's something you probably learned a while ago, several years ago, but haven't really been working on. But here's a nice, easy trick for getting rid of a fraction. Whenever you've got that fraction in front of your variable that you're solving for, to cancel it out, you just multiply the fraction by its reciprocal. Now, the reciprocal just means you flip the fraction upside down. You swap the numerator with the denominator. So the reciprocal of 5 over 2 is 2 over 5. Whatever you do to the left side, make sure you multiply by that same value on the right side. So looking at the left, the 2's cancel out, the 5's cancel out. I'm left with just x equals, on the right side, well, I've got 5 times 2, which is 10, over 5, and 10 divided by 5, sure enough, is 2. So we see that x equals 2. Da, 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 da. Wow, that was a lot of work just for one number. Because guess what? We still need to find the y. This is crazy. All right, so we know x equals 2. So I'm going to write that here. X equals 2. And so now I just need to plug it back into either of my equations to solve for y. Now remember, I'd originally gotten rid of this second equation, and we've rewritten it as y equals 6 minus 2x. Now I can still use that original equation for this part, but I like this version better because if x equals 2, I'm just going to plug a 2 in for x right there and solve it for y, nice and easy. So then y equals 6 minus 2 times whatever x is, and x is a 2. So y equals 6 minus 4, or y equals 2 as well. Very cool. We've got our solution right here. So my x value is a 2. My y value is also a 2. This is an ordered pair. That is the solution to both of those original equations. Therefore, it is the solution to the system of equations. Great job, everybody. All right, in this situation, we are going to solve one of them for a variable again, and I'm going to try to get this y all by itself. So I'm going to start by adding a 3x to both sides. So that top equation will now look like this. Y equals 2 plus 3x. Then to make sure I don't confuse myself anymore, I'm going to put a little squiggly through that first one because I've rewritten it as this new version where y is equal to 2 plus 3x. And we're going to substitute that in for y in the second equation. So let's rewrite that second equation now. Negative 6x plus 2. Now here's where the y would go. but I'm substituting it out. Instead of a y, I'm writing 2 plus 3x. And then the rest of that second equation after the y is an equals -5. All right, so now we just have to solve this for x. All right, I've got the -6x out in front. This 2 is going to be distributed inside the parentheses. So that's plus 4 plus 6x equals -5. Well, this is kind of weird. Look at this. If I combine my like terms, I have a -6x and a positive 6x. If I add those up, I get 0x. Well, 0 times anything is 0. So in this situation, those two terms actually cancel each other out. And I'm left with 4 equals -5 as my equation. And that looks kind of weird too. Now, if this ever happens when you're solving these systems of equations where the variables cancel out, they're completely gone, and there's nothing else I can do to solve for this because there aren't variables to solve for, you might be left with an equation that doesn't make any sense, such as this one. It says 4 equals -5. Now, does that make any sense? Is this a true statement? Does 4 actually equal -5? Well, no, of course not. They're completely different numbers. This is an impossibility. That can never happen. Now, in terms of what this means for the solution to the system of equations, if you ever get one of these scenarios where you're left with two numbers that do not actually equal each other, a false statement, what that means is this right here. Do you remember seeing that in our last unit? That circle with a slash through it? That symbol means that there's no solution to this problem. Meaning, if I look back at these original two equations here, there actually isn't a number or a ordered pair that I can plug in for the x's and the y's that would make both of these equations true. It's impossible. So anytime that this happens, when you get some weird equation that just doesn't make sense, like 4 equal to -5, we just say, hey, there's no solution here. That doesn't happen. And you're going to write this symbol, this no solution symbol, saying, hey, Wojcik, I tried it, but I can't solve this. No one can solve it because there's no solution here. All right, I've got one more substitution problem for you. All right, so I've got two equations here, and luckily one of them is already set up equal to y. I love when that happens, when there's already a y equals or an x equals. So y is 3x minus 1. I'm going to go ahead and substitute that in for the y right there. Let's rewrite that second equation now. 2 plus 2 times y, but remember, I'm not writing the y, I'm writing what the y is equal to. 3x minus 1. After the y comes this minus 6x equals 0. All right, so this is my equation now that I need to solve for x, because that's my remaining variable. We start by distributing in order to get rid of the parentheses. So now we have 2 plus, well, 2 times 3x is 6x. 2 times -1 is -2. Then after that part, I have this minus 6x equals 0. Okay, let's combine like terms. And oh no, look at this. 6x minus 6x. Those are going to cancel out again. That equals 0. Those are gone. And now I'm left with 2 minus 2 equals 0. Oh, but wait. There is a difference here with this problem. Because that 2 and -2, those are also like terms. I can actually subtract those from each other because they're just numbers. In fact, 2 minus 2 is 0. And does 2 actually, or I'm sorry, does 0 equal 0? Is this a true statement? Is this equation true? Well, yeah, it actually is in this case. 0 does equal 0. Yes, that can definitely happen. So if you ever get to this situation where the variables canceled out again, I can't solve for x, I can't solve for a y, but what I am left with is a true statement. 0 is equal to 0. So in this case, when it's something that is true, we would say that this has, it's kind of like that all real numbers scenario in our last unit, but I can't just say every number. Since our solution is the set of all like x's and y's, I can't say that every x goes with every y, because these have to be specific points, like specific ordered pairs or coordinates on the coordinate plane. And so instead, we would say that this system of equations has infinitely many solutions. So infinitely many solutions. So it's very similar to the all real numbers symbol. Remember that fancy R we had? But it's not just a single number. We only use that fancy R when we're solving an equation with just one variable. In this case, since there are two variables, we're saying, hey, there's a bunch of different ordered pairs. In fact, there's an infinite number of ordered pairs that would solve this system of equations. I can't list them all. There's an infinite set of them. So there's an infinite many solutions. What you can do, instead of writing this incredibly long phrase out, because it's 3 entire words, is I'm fine with you just writing IMS. So here's what I'd write in this scenario when the variables cancel out, and what you're left with is a true equation or a true statement where the left side, in fact, does equal the right side. Okay, that's it for substitution. Next method is elimination. Now, for the elimination method, these are your 4 steps. We're going to first set those equations up in a certain way, and we want to make sure that the terms line up vertically, meaning that they're right above each other. So the x's in one equation are right above the x's in the other equation. The y's are in line with the y's, and then the numbers by themselves, we call those constants, that the constants are in line with the other constants in each equation. Once they're set up that way, then comes this elimination step. And to eliminate, we basically add the 2 equations together by combining like terms. And when we do that, when we add them together, either the x's or the y's will cancel out. They're going to be eliminated. So it's like if I had a negative 2x and a positive 2x, they cancel out. Once you do that, we're going to have only one remaining variable. So just solve for whichever variable is left over, which will be either the x or the y. Once you solve for that variable, so if you solve for the x first, then you're going to plug it back into either one of those first equations and solve for the other. So then you could solve for the y, or sometimes you might solve for the y first, and you're going to solve for the x, just like we did with the substitution method. All right, let's take a look at a couple examples. So right here, got our 2 equations, our system of equations, and we want to make sure that they're all lined up. Now here's what I mean about them being lined up. Look right here, I've got the x's all in a line. Next to them, I've got the y variables in a line, and after that, I've got the constants all in a line. Now, an important thing is that they're also on the same sides of the equal signs, where the x and the y are both to the left of the equal sign, and the constants are to the right of the equal sign. It doesn't always have to be that way, but if you have like the y's on the left side in one equation, you couldn't have the y's on the right side in the other equation. So make sure they are all lined up, including those equal signs have to be lined up. So once they're set up like this, essentially what we're going to do is add these 2 equations together. We're going to add them up. And you just add the like terms, the x's with the x's, the y's with the y's, and so on. And if we look at this first column of numbers, so I think I'm looking at this grouping right here, well, I've got a 2x and a negative 2x. If I add them up, that becomes 0x, which is just 0. So I don't even have to write anything, right? They've canceled out. They're gone. They've been eliminated. But the rest of the equation still has some values. I'm looking over here. I have a y, and I'm adding 2y. Well, when I add those together, I'm going to have a total of 3y. Finally, that last grouping, I've got a negative 4 and a 10. I add those together, and I get a 6. And look at this equation that I have left over. 3y equals 6. Oh, you could do this in your sleep, right? Just divide both sides by 3, and y equals 2. Da-da-da-da. Boy, that was easy. But remember, this is not the final solution. We still have to solve for x. So I'm going to take this y equals 2, and I can plug it into either equation for y there or this y here and just solve for the x. Now, it doesn't matter which one I use. Take your pick. I think I'll just do this one up top. So I'm going to rewrite that top equation one more time. So I've got 2x plus y, but I actually know what y is. Y is a 2. We just solved for it. We got 2 equals -4. I'm going to subtract 2 from both sides to get -6. We see that x equals -3. Oh man, that was pretty easy. So now I've got my ordered pair. X is a -3, y is a 2. Box it up, everybody, because that is your solution. That ordered pair, -3, 2, will make both of those original equations true. Now, it's not always going to be this easy. They're not going to already be lined up. They're not going to have the same coefficients in front. It's not always going to be this great. If it is this great, that lined up that way, go for it. You got an easy problem. But let's take a look at some different scenarios that you're more likely to come across. For example, sometimes you'll need to multiply one of the equations by a constant in order to set up the variables for their elimination. So if I look at these two equations right here, if I've got my x's, they're lined up, but notice how they don't have the same number in front, that coefficient. This is a 1x, and that's a 6x. So if I just added these equations together right now, I'd get 7x, which doesn't eliminate. Well, let's look at the y's. Maybe the y's will cancel out. And again, this is like a -1y plus 3y. If I add those together, well, I'd get a positive 2y. Those didn't eliminate either. So we can't just add them up willy-nilly. We have to make sure they're going to cancel out first. And to do that, we need to look at that coefficient, which is the number in front of the variables. Now we get to pick. We can eliminate the x's or the y's. For me, I typically look at the signs, and I'm looking for opposite signs because I know that a negative number and a positive number will always cancel out. So right away, I see that the y's have one negative and one positive, but this y has a 3, where this one only has a 1. Wouldn't it be great if that equation up top had a -3y? If it did, then we'd be in business. We can add them up, and the y's would cancel out if I had a -3y and a positive 3y. Well, the good news is with algebra, with equations, you're allowed to multiply a term by a number, like 3, for example, as long as you multiply every term on both sides of the equation by that same constant. So what I'm going to do is multiply 3 times every term in that top equation. So I'm going to take 3 times the x, 3 times the -y, and most importantly, make sure you take 3 times that 4. A lot of times students forget to multiply that constant on the far side of the equation. So when I distribute this 3, we're now going to get a 3x minus 3y, that's what we were going for, equals 12. This is my new first equation, so I'm going to put a little squiggle through that to remind me I'm no longer using that equation. I've got 2 brand new ones here. And these 2 new ones should be all set up for elimination. If I add them up, I'm going to add them vertically. 6x plus 3x gives us 9x. 3y minus 3y, this just cancels out. There's nothing here, so I don't need to write anything. It's just going to be blank. Equals 27. Oh man, another excellent equation that's very simple to solve. All you have to do is divide both sides by 9. That gives us a 3 for x. Whew. That was fantastic. Now we need to get the y value, the y variable. I'm going to plug the 3 into any one of these equations. Now here's the cool part. For this, for getting that other variable, I can use that original equation if I wanted to, which I kind of do because it's a bit easier. It's a smaller equation. Or I could plug it into the big one, or even this new one that I made. I can plug it into any one of those that I want. You get to pick, and you're still going to get the exact same value for y. It doesn't matter which equation you choose. And so I'm going to take that x, or that 3 for x, and if I plugged it into this first one, we get 3, then the rest of that equation, minus y equals 4. And we're just solving this for y. So let's subtract 3 from both sides. Well, the negative y would stay put, but I'm subtracting the 3 from the 4 to get a 1. And then the last step, remember, whenever you've got a negative sign in front of a variable, think of that as like a -1y. To cancel it out, you're going to divide both sides by a negative 1, which ends up just flipping the signs of every term. So negative y becomes positive y, and positive 1 becomes negative 1. And that's our y variable. At this point, we've got our final solution, x comma y, or 3 comma negative 1. All right, so that one was one extra step. Not too bad. It wasn't terrible, but they can still get a little bit more difficult. Other times, instead of multiplying one equation by a constant, I might have to multiply 2 equations by a constant. So in this situation, if I'm looking at my x's, I want those to cancel out, meaning I want them to have the same coefficient in front. But this is a 2 and that's a 9, and there's no number I can multiply 2 by to make it into a 9. Excuse me, I should say there's no integer that I can multiply 2 by to equal a 9. I don't want to go by and like start multiplying 4.5 into my equation. Nobody wants that. All right, well, let's look at the other variable. That's a y. Well, I've got a 2 that I need to make into a 5. Ugh. I also can't do that by multiplying it just with integers. I'd have to use a fraction or a decimal. We really don't want to do that if we don't have to. So instead, we're going to multiply both equations by a constant. And I can still choose to cancel out either the x's or the y's. So I need to think about something called the least common multiple. For me, I think I'm going to look at the y values, and I see that there's a 2 and a 5. And I'm thinking, all right, what's the smallest number that 2 and 5 both go into? You know, what can I multiply 5 by or multiply 2 by to get to the same amount? And, well, hopefully you can see that that's going to be a 10. All right, so how do you get 2 to become a 10? Well, that's easy. We're just going to multiply it by 5. That second equation already has a 5, and I want to make it into a 10. Well, how do I multiply? What do I multiply 5 by to make it into a 10? You multiply that one by a 2. So we're going to go ahead and multiply each of these equations by their respective values to see what we get. So starting up at the top, I'm going to take 5 times each of these terms, including on the other side of that equal sign. 5 times negative 2x gives us a negative 10x minus 10y equals 5 times negative 24 would give us negative 120. All right, and looking at that second equation, I'm going to take 2 times each of these terms as well. Well, 2 times 9x gives us 18x. 2 times negative 5y, that would give us a negative 10y, and a negative 10y and a negative 10y wouldn't cancel out. So there's one more thing that we have to do in this situation. Because I want one of those y's to be positive and one to be negative, there's a very easy fix. All I need to do is instead of multiplying this equation by 2, I can multiply it by a negative 2. And by doing that, now this first term becomes a negative 18x. But the important part is this middle term now becomes a positive 10y, right? Because a negative 2 times a negative 5 is a positive 10. Equals, well, negative 2 times 10 is a negative 20. And now these are our brand new equations. We're going to go ahead and add these up. Now, negative 10x minus 18x gives us a negative 28x. The 10y and the negative 10y, those cancel out. They're completely gone. And finally, negative 120 and a negative 20 gives us negative 140. And again, nice and easy. They are bigger numbers here, but it's still a pretty easy operation, right? I want to divide both sides by this negative 28. And we see that x equals positive 5. Dun, 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 dun. We are halfway done with this problem. We still need to get the y value. So x is 5. I'm now going to plug it into one of my original equations. Again, I could use any of the 4 equations I have, but I like using those original ones because they've got smaller numbers. They're easier to work with. So either of these two. Take your pick. You're going to get the same answer no matter what. So if I take this 5 and plug it into, I don't know, let's go into that top equation. Let's write it out. Negative 2 times x, but instead of x, I'm writing whatever x is equal to, 5 in this case, minus 2y equals negative 24. And we just have to solve this equation for y. Negative 2 times 5 is negative 10. I still have the minus 2y equals negative 24. I'm going to add 10 to both sides. So negative 2y equals negative 24 plus 10 is negative 14. My last step is going to be dividing by a negative 2. So y equals a positive 7. At this point, I've got my ordered pair. My x is 5 and the y is 7. And there it is. Our solution to this system of equations is 5, 7. All right, so now you're seeing that there might be a little more work with elimination than you originally thought. So if you can use substitution, that's great. But these original equations didn't lend themselves well to elimination because there were coefficients in front of everything. Or substitution. I couldn't just solve for an x or a y. So in this case, I turned to elimination instead. And we still got our answer. Now there's one more thing that I mentioned back at the beginning of this elimination method, is you need to sometimes rearrange equations so that everything lines up, meaning everything's on the same side of the equal sign. So right here, do you see how I've got a y on the left side and here the y is on the right side? That's not going to work. Or how I've got the x and the constant on one side, but here the x and the constant are on opposite sides of that equal sign. That doesn't work. So we've got to rearrange things to get them all on the same sides of the equal sign. So what we can do, let's see. I am going to move the x's over to the left side. And I can move the y over to the left side also. So let's move both variables to the left. So I'm going to add 1/3 x plus 1/3 x on both sides for this first equation so that those cancel out. And then here I'm going to add 6y, add 6y, so that the 6y's both cancel out. Then I have the x's and the y's both on the left side, and then these constants will stay on the right side. Okay, so once I do that, then this first equation is going to be 1/3 x plus y equals 5. My second equation would be 6y plus 2x, but remember, I want the x's and y's to line up. So I'm just going to write the x's first, 2x plus 6y. Oh, not 5, this one's 30. Equals 30. So these are my equations that I'm going to use. All right, so now they're all lined up nice and neatly. And I want to cancel something out. Ugh, look at that. 1/3 x, I don't like that. So let's try to cancel out the y's. The second equation has a 6y. I need to make this into a 6y or a negative 6y, right? Because we want them to have the opposite signs. Since I've got 1y, I can just multiply this first equation by a negative 6. All right, so we're going to distribute negative 6 times each of these and see what we get. That first term, well, a negative 6 times 1/3 x. Well, negative 6 times 1 is negative 6, and negative 6 divided by 3 is negative 2. So this is negative 2x. Then I'm going to take negative 6 times y to get negative 6y. And then finally, negative 6 times 5 is negative 30. Okay, let's go ahead and add these equations together and see what cancels out. Well, 2x minus 2x is 0. 6y minus 6y is also 0. And over here, oh man, 30 minus 30, that's 0 too. Huh. I wonder if this is one of those special cases again. 0 equals 0. Dun, dun, dun. The variables all canceled out. And what we're left with is this equation that says 0 equals 0. Well, is this true? Yes, this is true. That's good. That means that we have infinitely many solutions. If you remember from our substitution problem, we can just write IMS. So that's pretty much it, everybody. That was substitution and elimination. I hope you remember some of those from back in the day. And go ahead onto Delta Math right now and try some practice problems. See how well you do. As always, send me an email or a message or whatever if you've got some trouble, if you don't understand some of these, and I'd be happy to help you out to go through them. Do the Delta Math. You can watch the help videos there also. And hey, have an awesome day. Bye, everyone.